Okay, question 11, it says define acceleration. So acceleration is defined as the rate of change of velocity, or acceleration is the change in velocity divided by time. It's a definition which you must recall for your A-level exam. State why acceleration is a vector quantity. Now, you need to address the idea of what a vector is. Okay, so a vector has size and direction. So acceleration has magnitude and direction, and that's what you need to say for that. Part B, it says state what feature of a velocity time graph may be used to calculate the acceleration. So on a velocity time graph, the gradient is what we use to find the acceleration. Part B2, displacement. How do we find the displacement on a velocity time graph? It's the area underneath the velocity time graph that will give us the displacement. Part C, we have a graph here of displacement against time of a runner from a fixed point along a straight track and how that varies with time. So it's displacement and time. So you can think of it as distance time, just to kind of make a parallel in terms of a link. But remember, displacement has direction as well, and because it's a straight line, we can say that that's distance. Now, it says without calculation, sketch on a grid on the grid figure 2 a graph to show how the velocity of the same runner varies over the same period of time. The time scales are the same on both graphs. So we know that from a displacement time graph, the gradient of this graph is velocity. So we are looking at the gradient. So what we can see is around about from roughly around about 2 seconds, and to around about um, 6 seconds, roughly speaking, we have got it's almost a straight line. You could argue that it's slightly later than 2 seconds, or slightly before 6 seconds. And a straight line on a displacement time graph signifies constant velocity. Okay, so we are looking for a straight line between 2 and 6 seconds horizontally across like that. Okay, because the gradient is constant, so that the velocity is constant. Now we can see that the gradient is increasing, so it's sloping upwards. So if you do a tangent, you can see that the gradient is increasing, the steepness increases. So that means that if the gradient increases on a displacement time graph, the velocity increases. Now, do we know whether that increase is linear? So it's constant increase. We don't, but we can make an assumption that it's a constant acceleration. So starting off from 0 to some maximum here, where we talked about leveling off, the speed increases. So from here to for 0 to 2 seconds, we know that the speed is increasing as the gradient increases. From 2 to 6, gradient is constant, velocity is constant. And from 6 seconds to approximately around about 8 seconds, so around about here, we see that the gradient decreases. So that means that the speed decreases. And it decreases to 0 because we can see that the gradient here is 0, so therefore the velocity is also 0 after 8 seconds. So it's decreasing in velocity from 6 to 8, and then we need to have a straight line from 8 to 10. Okay, so we're looking for 1 mark, 2 mark, 3 mark, and 4 mark there, to get all of the marks for this particular section.